Hello, this is Ahmed with Microsoft Group. Today we are going to have an introduction to ansys Fluent. First of all, please subscribe our channel, like our video, and tell us any opinion you have in the comments. It will help us so much. To start it, we'll go to this slide. It can help us a lot. First of all, let's know what CFD is. This is the science of prediction of flow, field, heat and mass transfer, chemical reactions and so on numerically. This kind of science completed numerically, and it can help you about knowing the heat exchange, knowing about the mass transfer and other factors you need in a flow analysis. The applications are about new design. For example, imagine you want to design a new motor, so ansys can help you so much. Ansys Fluent. Or sometimes you want to develop a product, you want to optimize it. Perhaps for many years people have been using some geometry for a special machine, but sometimes after some analysis you use in ansys, you may find some new way, some new design using this software. The other is solving the current problems of the mechanical system. For example, imagine you may face a natural problem. You want to check the amount of water in a lake, so perhaps you can use ansys Fluent to solve your problem. And sometimes you want to redesign, it can help you so much. Imagine you start working in a factory, you may face different machines, different places. People have been making so many mistakes so far, but after analysis you will understand that by using less energy, by losing less money, you will have the same results. So it can help you so much to redesign some productions. The other is some products. Sorry, the other segment of the slide is how it works. It is an important question in everybody's mind, how ansys Fluent finds the answer. There are some equations, as you know, in mechanics of fluid, in heat transferring. If you solve them, you will have the answer. But here, by inserting different amount of numbers, we will find out about the answer. The equations like continuity, like momentum, like energy, like species transport and radiation, which are completely spoken about in the other videos. Please go for them. Here we want to speak about the steps we have to go for to solve a problem in ansys Fluent. The first one is geometry drawing. You have to explain what the geometry of your problem is in during your solving process. For example, you want to analyze a pipe. You want a circular pipe or a cubic channel. These are different, so you have to model it. And some people ask, we have to model it in ansys or not. There are two ways. You can model it in ansys, but most of the time I personally do not do it unless the process is short, unless the modeling is simple. But if it's complicated, it's better to go for softwares like SolidWorks, like CATIA, like Inverter. And by using them, you will have a 3D design. By saving them as IGES suffix, you will be able to insert them in ansys. After inserting the geometry or modeling it in ansys, you will go to meshing. Meshing makes some segments in your model. For example, something like this. This is a vessel. Sorry. Imagine you have a vessel. You want to check whether it can stand against the stress you want or not, because your blood has some pressure, and if it increases, it may tear. By ansys Fluent, by making different meshes like this, like the squares you have in the picture, it starts solving the equations I told you, like equations of moment, or equations of energy and things like this, to know about every data you need in every cell. So this is how meshing can help you have CFD science in your problems. This is what meshing is. We will explain about it further in the next slides. The other is a physical setting. Sometimes your model is transient, sometimes it's steady. As you know, a steady is a kind of flow which, for example, imagine a pipe transferring water from one place to the other place in your home. This is a steady flow because the water always goes through your pipe, and the condition does not change by time. But if your model changes by time, for example, imagine you are pouring some water from a glass on the ground. So this is a transient problem. You can use both of them. The other is materials. Imagine your pipe can be made of steel or gold or copper or anything like this, or even the flow can be from water, can be air or other fluids. So the materials is important for ansys. The other is boundary condition. For example, you have a problem, you know about the inlet velocity, you know about the inlet pressure. By inserting them in the software, you will know about the other factors. For example, you insert the inlet velocity, and after calculation, the software will tell you about the outlet velocity and things like this. The other is solver setting. You need a different convergence criterion. For example, imagine you want to solve a problem by inserting numbers in it. You want to solve an equation by inserting numbers in it. If you, for example, insert 5, the amount will increase. If you insert 7, the amount will increase. So you haven't chosen right numbers. This is how ansys works. Inserts number in equations and checks whether the answer is getting better or worse. If it's getting better, it will continue the decreasing or increasing. And if it's getting worse, it changes the way. We will speak about it further. The other is solution. Imagine you have inserted a problem, you have solved it. Right now you have a solution. You inserted, for example, inlet velocity, and the software told you about the outlet one. Right now you know both of them, you have the solution, so you can decide what to do by changing some geometry, by changing the materials. You can have different results, so it can help you a lot in designing process. The other is post processing. You insert your geometry. Imagine, first of all, you do the meshing, you insert your models and boundary. Design, there's a problem with the pipe you have designed. So like this, you can change the conditions. For example, changing the geometry, changing the geometry, changing the materials can help you so much. Changing the boundary conditions, by changing the factors, you will go for your interested result. And if all the others were not showing good results, so there's a problem. You have to change your models, you have to change your materials to find a good result. And if not, you have to restart it again and use some other ways. The other factor we must know is that before going to ansys, before going to fluent, we must know that what we are looking for. Imagine you are checking a pipe. This is, imagine, let me perhaps draw it for you, it will be better. Imagine this is a pipe, and this is how the flow moves in it. Okay, so here the pressure in this part and this part is different. So if you want to know about it, you can use ansys analysis to know about it. This is pressure drop, or for example, imagine you want to know about the heat transferred between two hot elements. These are some examples, perhaps many problems. Even NASA is using this software to go for its solutions, so it can help you so much in any problem. The other is what kind of models do you need? It is turbulence, this is radiation. For example, imagine you want to check the hot water going through a pipe. It is not rational to think about radiation, because radiation mostly happens in high temperature. Or imagine you are checking a big channel, and perhaps it's not possible to have a turbulent flow in it, so it's not rational to choose turbulent. According to some science, you can get better results using this software. The other is what assumptions are involved. It is symmetry. Imagine you are solving a problem having symmetry relations. Sometimes you may have constant properties. Imagine air, the factors like Cp varies from one temperature to others. You must know about it. If you want to start your calculation, you must know about the special amounts of air, and then go for solving some problems. If you don't know about them, you cannot solve your problem, and or the results will not be rational. The other is convergence, as I told you before. If you insert some numbers in your equation and the amount you catch is not rational, it's getting so big or it's getting so small, it's not rational, you change the numbers. But know that these are all automatically done by the software, and here we are to know what the software does. It's not necessary to be worried about how to solve the problems. This is what ANSYS does. Just we have to introduce any factor involving our problem, and it will automatically solve them. The other is that whether CFD can help you or not. For example, imagine you want to check some loading on a beam, so CFD cannot help you. This is not a good way to go for CFD for such problems. It is a good idea to talk about this slide. After all, look at this equation. Perhaps it can help you know about how it works properly. X in power 2 minus 4 equals to 0. I put r instead of 0, so here r equals to x in power of 2 minus 4. As the first step, I insert 4 instead of x, so 4 in power of 2 minus 4 will be 12. Right now I can increase 4 or decrease it. For example, let's decrease it. So I insert 3. 3 in power of 2 will be 9. 9 minus 4 is 5. As you can see, the amount of r by decreasing the inserted number decreased. So we are going through the right way. So let's decrease it for one step more. Here I insert 2. When I insert 2, 2 in power of 2 will be 4. 4 minus 4 will be 0. So right now r equals to 0, and I know that as starting from 4 and decreasing will bring me better answers. This is how ansys fluent works either. It tries a special number as a beginning, and step by step it decreases the number or increases it until getting a good r. After getting good r, we can make sure that the answer is the right one. Here it was a simple equation. Imagine it, for example, we have I don't know, billions of equation. In this way, you will have a really hard work. This is what ansys can do for you. It's our pleasure to be at your guest in your home. I hope you have enjoyed our videos. Please tell us if you have any points for us in the comments. Like our video, subscribe our channel, and keep watching our videos, because first of all you have to know what is truth in ansys, and after go to the software to work with. Good luck and have a great time. Goodbye.